Thank you, everyone, for coming out today to the first of three workshops for the Algorand Hackathon. This one being a technical workshop, and we are joined today by Russ, who's a developer advocate for the Algorand. Without further ado, Russ, you can go ahead and get started.
Oh boy, we're on. I hope everybody's doing well today. I know that I'm pretty excited about delivering this session. I got a really killer demo to end with here on Reach, and we're going to have a detail session coming up on Monday. So this will kind of give you a precursor, get ready for that, maybe do some homework and prep for that session. But nonetheless, it's going to be really cool. So thanks very much. I also have Chris on board here from Algorand. And Chris, you just want to introduce yourself and say hi?
Yeah, thanks for the introduction. Hi, hello everyone. I'm Chris. I'm a technical product management intern at Algorand right now, and I'll be helping out with answering any questions.
Thanks, Chris. And Chris has been doing a killer job for us, really contributing quite a bit for DevRel. All right, so let's go ahead and get started. I want to get to know you. I want to get to know your experience level a little bit. So I do have a poll here. If you can please join that poll. And what I'm going to do is go out to it. You'll see it actually listed up here. So either just scan the QR code that you'll see here shortly. There it is. And go ahead and start answering these poll questions. I got 3 of them to gauge your experience level. So what is your experience with Algorand blockchain is the first one. Are you guys able to see that okay? Yep, okay, now we're getting some responses here, very good. Less than 6 months with any blockchain, less than 6 months with Algorand. You can select a couple, 2 of these on this list. And then also less than 6 months and more than 6 months as well. All right, so we've got brand new to blockchain. Looks like we got 43%. Okay, now it's an equal distribution. Okay, this jives up basically with some of the stats I saw earlier. We've got about maybe a quarter of you have already done some stuff with Algorand blockchain. All right, good number of you. All right, so we're at about 40% for 6 months or less, and then there's about a quarter of you are brand new. Okay, that's good. So the next poll question, let's go ahead and go out here. What languages do you prefer to code in? Check all that apply. If you're not a developer, go ahead and check that one on top, but we got Java, Python, JavaScript, Go, C#. And that's very good. We have a lot of demos in different languages, so this will help me gauge which ones you're mostly interested in. Top on top, once again, is Python. That's very consistent in pretty much all the sessions I deliver, except when I'm delivering to like a C# group or something like that. But all right, very good. All right, we'll move on to the final poll question, and this is experience building dApps or distributed applications. If you're brand new, put that in. Otherwise, some experience with PyTeal, some experience with Teal, and built apps on Ethereum, and also have built dApps on Algorand. So let's see, this would be a very interesting poll here to see if I really encourage everyone to participate that's here in voting on this question here. Half have done Ethereum. Okay, that's very interesting. The good amount are brand new. And other blockchains, it's interesting. Okay, I've built apps on Algorand, about 25%. Some experience with Reach, that's good. We got 18% there. And Teal, we got a little bit of experience. Okay, this is great. So we are all across the board and a very distributed audience today. All right, so let's go ahead and continue on here and get into the meat of our session. And Georgia, and I just want to ask if you got the recording going on this right now?
Yeah, all live.
Okay, all right, great, thanks. Well, thanks everybody for having me. Russ Fustino here from Algorand. We got blockchain. We're going to be covering like a rehash here for some of you. Many of you it'll also be brand new. So we'll kind of hit the mark right in the middle in terms of the presentation and the content. When I'm developing a blockchain solution, I'm just wanted to share with you some of the thoughts I have in my mind, and maybe it'll be similar to yours, especially how when you're doing a hackathon and you got to come up with a solution to build, right? So what type of solution can I build anyway? As well, especially for those that are new to blockchain, and what programming languages, can I use to do it? And can I reuse any of this code perhaps for another blockchain? Another question might be, can I have interaction with one blockchain with another on a transaction? Actually, I think just about every seminar we do, we get that question. So stay tuned for the answer on that one. And how do I verify smart contracts? In other words, audits, especially we start getting into, building dApps. You really have a responsibility as a developer to really make sure that there's no holes in that smart contract, holes in particular that might leave funds stranded and unrecoverable due to failing to maybe spend everything in that contract that was desired to do so. So we're going to talk about that as well today. So the sections we're going to cover here are blockchain solution ideas that give you, kind of some food for thought in terms of what you want to build. Getting started, primarily for the brand new folks, that'll be pretty quick. And then we got a dive into layer one and then some really great code and tools to show you here today. So what can I build with Algorand? Well, I'm going to show you a few case studies, but there's a common theme on all of them. They all seem to have the same traits or characteristics. One of which is the desire to have a public and open solution. And that is also another attribute there is decentralized, right? So we want this thing to be globally accessible, be able to do transactions globally. Also, it's nice to have a tamper-proof solution. Many times you may need to have an audit trail into a solution that you're building. Well, with blockchain, it's built right in. Also, you want something that's performant and fast, right? High throughput, transactions per second. It's got to be very high and performant. Look at Algorand's blockchain. You have transactions that are under 5 seconds each to get created to the block, and then also over 1,000 transactions per second. Both those numbers are improving. Solutions are combinable on layer one features. You're gonna, those that have also already dabbled into Algorand, you'll notice that your end result, your end solution is really going to combine things like maybe Algorand standard assets, as well as smart contracts, as well as, atomic transactions or transfers, for example. So it's not just one technology that typically makes it up. So we'll be going through a little architectural diagram and a little bit how those fit all together. Also, what are my dev tools? This is for any project, right? You want to get familiar with, number one, first and foremost, the SDKs. Number two, the REST APIs, right? And number three, the integrated development environments, and maybe a fourth might be additional tools, right? That you can utilize for that. How about deploying, right? Well, you're going to end up deploying your solution like you will most other applications, right? To the web, to the desktop. You also have maybe to devices in the way of apps on iOS and Android. These are all different places that you could do your deployment to. And then also dApps, and right, perhaps to multiple blockchains, right, with reach is another type of trait. And I think that's a very important one, especially for the Ethereum developers that are out there. when you're developing any other Ethereum apps, then you'll basically get an Algorand app free of charge because the same code works in each. And I'll go into depth on that in a little bit. For the brand new folks that are to blockchain here, what type of apps can I build? You got public and open, which is the nature of this and of the Algorand blockchain, as well as other public platforms like Bitcoin, Ethereum, Litecoin. And this is what we refer to as permissionless blockchain platforms, meaning they really strive by design to increase and protect the user's anonymity. Basically, you can always use these public and open platforms to build a permission solution, however. So you got to think of that in mind. So you have in the upper right, currencies, betting, video games, all public and open, all the way down to the bottom left where you got private and closed, which might be construction, national defense, law enforcement, military, or tax returns, the things that you want to have maybe an authentication piece to get at that type of information. Well, you can actually do that a few different ways, one of which is we have a note field that you can use in transactions, for example, that could help facilitate a permissioning model. And that's really up to the developers and the developer staff to kind of come up with that. And so any layer 2 app can build anything permission they want. Algorand just won't enforce any permission rules itself on the blockchain itself on layer 1. So that is kind of the quick and dirty on that. So really a lot of these different types of solutions are possible really when it comes to doing blockchain solutions on Algorand. So let's get into a few examples. Yieldly is one of the newest examples I want to point to. They provide bridges and staking and no loss lotteries. And then the bridges are actually cross-chain solutions. We had that as one of the questions up front, right? Can I talk to another blockchain over a bridge perhaps, right? So they're going to expand other protocols in this cross-chain solution to Ethereum, Binance, and Polkadot. What they have done already is they have an ERC20 bridge between Algorand standard assets and the ERC20 ecosystem. So that's already in place. And then you got staking where the users earn passive income. And then they have no loss lotteries where you can stake algo to maximize potential gains. And there is actually a session on this we're doing on Tuesday at our developer office hours. So you might want to make note of this, take a picture of this or whatever. We've got the developer office hours coming up, and that's going to be at 9 a.m. Eastern Standard Time here in the States. And so that'll be a very interesting session if you want to learn more about how they actually built this particular platform. Then you got Bloomy is a non-custodial cryptocurrency payment platform. So, this works with any ASA and any future central bank digital currency or CBDC built on Algorand. It also can be integrated by businesses of all sizes and payments, payouts, security. It's kind of like PayPal, on the blockchain. And so Bloomy Pay supports a lot of payments through e-commerce plugins. I got a bunch listed there, as well as all a business needs to do is just download the plugins and they can start accepting cryptocurrency payments. So very cool product. And they also have APIs and SDKs and point of sale systems available. Then we get to Circle and Coinbase, and this is just mind-blowing. Payments and treasury infrastructure on the internet. You can accept payments, send out global payouts globally. And the part that's really blowing my mind is the fact that the beginning of this year, USDC, which is a stable coin. And let me just stop there a second. The stable coin is a form of cryptocurrency. But one of the problems with native cryptocurrency, even like the algo or the Bitcoin or any other native cryptocurrency, it really tends to fluctuate quite a bit from day to day. It could be really high and really low, and it makes it very difficult to do transactions, when you have that kind of flux. So what a stable coin is tied to an economy. In this case, it's tied to the US economy, USD. And C is the central consortium that was developed between, Coinbase and Center. And at the beginning of the year, they had 4 billion in circulation. Now, just a little over half a year later, 22 billion in circulation. It is just incredible how this is taken. It makes sense, right? So you have a circulation that kind of works like money, right? In the fact that it doesn't fluctuate as much as normal cryptocurrencies do. And now you have a way to do transactions that are consistent. This is one of my favorites here, the Italian Society of Authors and Publishers. Now the other ones were more DeFi, in the DeFi space or distributed finance space. This one here is using NFTs, which is, you know, all the rage this year, it seems like. NFTs that are brand new to folks are non-fungible tokens. Each one of these are unique. And for example, what they did is put copyrights on the Algorand blockchain. The copyrights would be for over 95,000 creators, and they've got over 4 million NFTs out there, copyrights. That's a really great idea, right? Because each one of those copyrights are unique, and they're one of a kind. So the way you can think of an NFT is like a collectible or something that's very unique. A lot of different data, that's metadata that's associated with each one of these NFTs that make it unique. It's also decentralized and transparent public blockchain. So it means you can get at this proof of copyright anywhere in the globe, anywhere beyond borders, right, of countries. It's a global and open infrastructure, end-to-end protection, and it's really the future of this industry, the copyright industry, similar to what they did. So very cool stuff there. Oh yeah, and there was even a skit on Saturday Night Live a few months back about NFTs and blockchain. There you can see non-fungible tokens. It was like a rap song, like, what the heck is an NFT? It's really funny if you get to see a rerun on that. All right, other use cases, it's just, again, to get your mind thinking. It's not just about DeFi, but there's a lot of other verticals, tamper-proofing charity organizations, again, that were tamper-proof, right? You know, it's basically a read-only ledger, read once, write many, and then yes, also, it's a read-only ledger and write once. Now I said it correct. And so when you're writing it once, you're actually writing the new transactions that are associated with that chunk of time in that block. So these are real examples here. The China Ministry is using that to improve the transparency of social services and tracking donations in an audit trail. You know, there's been bad experiences there in the past and have caused problems, not knowing where all the funds came from, where they all went to. And again, that was for charity. So then also got tamper-proof voting. Again, the tamper-proof is the key there. Healthcare, you want global access on that. Medical records available to the treatment team, no matter where they are. You don't need to spend a half hour updating all your medical records every time you see a new doctor. You should be in control of your own medical records. Right, that's the idea there. And then automotive supply chain visibility, you know, they're looking at they're actually doing it, putting sensors in the engines now to provide history on the wear and tear of the car. And again, all that written out to the blockchain. DeFi apps exploding, like we talked about this year, expected up to $3 trillion are forecast in the blockchain industry. These are the challenges. Jason had showed this last week a little bit that we're primarily interested in here at Algorand is doing solutions in PyTeal or Reach built dApps. You can implement a decentralized naming service. That's one, I think, and each one of these have examples with links on it. So you might want to take a picture of this. We will provide the deck at the end, the link to the deck at the end. So you'll have all the links to that are used in this session. And then the second one is a decentralized perpetual contract trading dApp, and then the crowdsourced membership insurance app. So those are examples of something similar to do. Blockchain essentials, this is it, really. You got the Algorand blockchain is an immutable distributed ledger. And everyone can have a copy of it. You have a node, you got a copy of this ledger. And there's 5 types of record types that are in this ledger. You got a ledger, you got blocks, which are a chunk of time. So every 5 seconds, a new block gets written out to the chain. And the blocks have associated with them transactions. So you can have one-to-many, there's a one-to-many relationship there between one block having potentially many transactions. And who are the transactions between? Well, they're between accounts, from one account to another, sending, receiving. And the accounts also have associated with them assets, which are your tokens that you can create yourself, and then applications, which are your smart contracts. So that's the lay of the land. Very, very simple when you think about the structure of the ledger in terms of, it's not really a complex thing here, right? It's very, very straightforward. And really just this design really facilitates a good number of solutions. Lastly, we got the Algorand Pure Proof of Stake protocol. We got some videos up on this if anybody is interested in watching more of this on the site. But the bottom line here, it's got true scalability with, over 1,000 transactions per second, under 5-second block times, like we had mentioned. Infrastructure longevity, along with a lot of technical flexibility, a lot of SDKs, transaction certainty. There's no forking, there's no mining. Everything gets done very, very quickly with verifiable random functions and our consensus protocol that you're looking at right here. Very energy efficient. You can run a node on a Raspberry Pi. We are strive to be the greenest blockchain around, and also very, very cost efficient, and provides true security. The cost efficiency is huge. Those that are coming from Ethereum are looking at the high gas fees or transaction fees, right, that are associated with Ethereum transactions. It could be $20, $25, $30. These are typical costs that I've heard. With Algorand, the cost of a transaction is a 20th of a penny. So very big difference there. And a lot of vendors and companies are realizing this, and they're coming to the Algorand blockchain because of that. Getting down to some meat here now for the heart and soul of your solution. We see Algorand accounts with, we're going to talk about rekeying, what ASAs are, atomic transactions, and a refresher, and then also smart contracts and reporting with the indexer. So very upfront, very simple. There's 3 types of accounts. You've got a standard account, which could be represented by an individual or a company, let's say. And then you got a multi-sig account, which is made up of kind of like, you think of like a board of directors or something like that. But basically, it's a team of people, and you specify what the threshold is when you're building a multi-sig account. How many of those would have to sign off on it for this transaction to be approved? So let's say you've got a team of 10, and you want at least 5 people to approve this before it gets signed and sealed and delivered as a transaction. Well, the threshold there would be 5 then. You have to at least get 5 of those. Or if you wanted at least 6, so the threshold would be 6. Then the logic account is actually very, very useful in if it returns true, then the transaction will be signed. If it returns false, then it won't be. So you might have some additional logic that might be associated with that, and we'll show you a few demos on that as well. Some details on ASAs, just to give you more of an idea. There's 2 types, right? You got the fungible, which are things like in-game points, stable coins. Every one of these is the same. They're all created in like lots of quantities, right? Cryptocurrencies, for example.
I'm having trouble hearing you.
Siri's yelling at me on my phone. I don't know what happened there, but anyway, and then you got non-fungible tokens. You've got in-game items, supply chain, real estate, identity, certifications. We saw copyrights, right? Those are all examples of non-fungible tokens. So real estate might be an example, might be you've got a condo, 2-bedroom, 2-bath on one part of town, and then you got a same condo kind of structure in another part of town, but they're in different areas, different neighborhoods, different amenities nearby. Maybe there's a pool there, maybe there's not. I mean, there's a lot of different things there that would go into the cost of that particular condo. So there's a lot of metadata. So things that make it unique. So each house is unique to a certain extent there. So those are all examples there. Then you got non-fungible tokens, restricted. Restricted provide ability to do clawback transactions and return funds back. Let's take a look at AlgoDesk. This is a great tool to go ahead and build an asset visually. Let's go ahead and load up our assets. Let's go ahead and create a new one. Let's go to Pizza Russ. We got 10,000 we're going to do. You can have a decimal point associated with this. And now this 10,000.0 would be the total supply. If you wanted to do an NFT, it would just make the supply equal to 1. is what you would want to do there. And then let's go ahead and create it. So now, again, this transaction will be under 5 seconds. It's going out to the blockchain and writing this out to the blockchain. Once this completes, we're going to scroll right down to the bottom, and you can see this new one that we just did here, Pizza Russ. And this is the manager address. And all these addresses are the same, but you can go ahead and make those differently. Different functions for different accounts. There's a reserve address, there's a freeze address, and a clawback address. So each one of those are responsible for those items. I can open the asset here. I can also click on this, and this is going to give me the ability to send, modify, freeze assets, unfreeze. These are all API calls, right, that you would have available to you to do if you're doing this programmatically. Let's go out to the browser. So this is one of the browsers that we have. This really shows you we just created this 50 seconds ago. And then you have information about, general information about this particular asset. In particular, the ID. The ID number is the unique identifier for this. The unit name is not necessarily unique, and neither is the actual name of the asset. And that's the lay of the land there. There's also a browser from PureStake. Let me go ahead and just get this creator address here, for example. Let's go ahead and copy that off, and I'll go over to Goal Seeker by PureStake. This one we were just looking at was Algo Explorer. And you can see we've got testnet and mainnet capability. I'm going to go to that same account. So really the nice thing about these tools, you can get instant information about it. And there you can see mainnet, testnet, betanet available to it. All right, so those are kind of like the, oh yeah, and I did want to mention that there is a developer portal on each of these, and additional services are provided by PureStake in the way of having nodes already created and accessible to you. You can just use those as is. And the same goes for Algo Explorer. As you see right here, there's a developer API, so you can click on, for example, this information here, and you can see the endpoint that you would need for REST API calls. And then there's a lot of different functions here, and they have the ability where you can try these out right here. All right, so that's kind of that demo. And then let's take a look at Algo Signer. So Algo Signer is a Chrome extension. It allows you to facilitate signing of transactions. So you can see here, I've got a testnet transaction. I've got a Russ account. And all I'm going to do is copy off an address here to paste in here. I'm going to send some funds. I'm going to send one algo, and I'm going to go to this particular address. You can send it. And then you should see successful. And then you can take this transaction ID and copy it, and then go back over to the Explorer. And you see you can search by transaction ID, group transaction ID, block, asset name, asset ID, app ID, or by account address. And now there's that transaction that we just did instantly. So very nice. There's a few other tools like this. There's MyAlgo is it's not a plugin. It's actually just a web-based solution that you can talk to with your applications to do the signing. And then there's a few more tools as well. All right, so that's our first demo here of the day. Let's get back to the deck. Continue on.
We have a few questions in chat, Russ. I don't know if you want to address some of them now or later.
Yeah. Go ahead, fire away.
Okay, there's been quite a lot, but Chris has been able to answer most of them, I think. Chris, do you know if there's any that you haven't been able to answer, or you'd like Russ to jump in on at all?
I was able to answer most of them. I'm not sure if Russ will. Okay, there's one. Someone asked how many daily users do the biggest dApps on Algorand have, but I'm not sure if we quite know. if there's a way
That's
to
a
find
good
out
question
right
to
now.
ask at your next session with Jay. I think he's going to deliver the Reach session. So he has an answer to that, and I've heard him answer it. I just can't remember what he said. So I don't really have a definitive answer on that one. So we'll have to push that off until I think you got a session on that on Monday.
Yeah, I'll
And
just send a link in chat for that for everyone now.
also, another question just came in. Is there a multi-sig management tool for Algorand?
Multi-sig management tool for Algorand?
Yeah.
You can actually use multi-sig in your SDKs, and there's an example of that up on our in our developer portal on how to do that. If we get a chance, maybe I can sneak that demo in as well. So in terms of an actual tool other than the SDKs handling multi-sig accounts, I have not seen that. So that might be a good project to do during the hackathon. Cool. Anything else for now?
I think Chris has managed to answer the rest. So
that's great, Chris.
Fantastic.
Keep it. I so appreciate you answering those questions. All right, let's talk about atomic transfers here. All must succeed or all fail. Kind of analogous for those who are familiar with SQL Server or any kind of SQL database, where you want to accomplish several things, and you want all of them to happen, or you want the database to roll back the way it looked before the transaction. Same type of thing here. Either they all must succeed or they're all going to fail. You can tie it together up to 16 transactions. This guarantees an exchange of goods, and you can combine this with other Algorand technology. So here you see a person A is going to send 50 algos to person B, and return person B is going to send a concert ticket to person A. Well, if this second step is not completed, this person A is going to get their 50 algos back. It's just that simple is how it works. And so everything has to be completed in order, and the person B is not going to send a concert ticket unless they get the 50 algos. So this really provides a way for you to do transactions with people that you don't know and be very, very certain that's going to go through. Examples of this are things like reduced counterparty risk, circular trades, multilateral trades, group payments. Also, you can combine all these technologies together, and really the atomic transfer sometimes is the secret sauce to tie together a solution when you're working with ASAs and smart contracts. Here we get the transaction execution approval language, TEAL, for smart contracts. We talked about PyTeal, which is basically a Python that generates TEAL for you. So that makes it a little bit easier for those that don't want to dive down into an assembly type language. And the reason we're using TEAL on the blockchain is it's very efficient, right? You don't want to have a very heavy VM out there to weigh down transactions and performance. And so that's why we have that decision. And then we got Reach as well, and we'll show you that in a little bit. Two types of smart contracts, stateless and stateful. You got stateless to approve spending transactions, as well as stateful that also provides the ability to store information on the blockchain globally or locally at the account level. And again, these are all combinable with technologies. Finally, we get into the indexer, which allows you to report on data in the blockchain in an efficient manner. The AlgoD process is a daemon that you can utilize to do your queries against the blockchain. We use it here to populate a PostgreSQL database, and this is accessible from all the SDKs. You can set that Postgres database up yourself, or you have one that comes by default in the private network of the sandbox. So if you're installing a sandbox tool, then you can, if you just do sandbox up, that'll be the private network, and that includes an index instance. Also, those services I talked about, PureStake and RAN Labs with the Algo Explorer, you have the ability to access their indexers that they have already set up, or you can build your own. I built my own. It's very, very large. Several gigabyte, probably about 100 or maybe 150 at this point. And then finally, we get into layer one, kind of like architectures, right? Putting a solution together. You got layer one features on voting. For example, you might have a commission account, spending token. Now, these are all atomically grouped with atomic transfers. So all of this has to work, or none of it does. Then you do the voting with a smart contract, for example, and that's going to increment a candidate total in global state. Crowdfunding, same type of thing, where you have a product, you want to get some funding done, and then once you get the funding done, then you give the product out to all the investors, and basically you get a crowdfunding escrow account, which is a stateless smart contract, again, atomically grouped, and then the payment goes to user one, and then user one claims the escrow funds through a stateful smart contract. So there we're combining both a stateless and stateful into an atomically grouped transaction. So getting on the tools, you can build your own node. We got great doc on our sites on how to do that. Fast catch-up is here, so it only takes minutes rather than days. PureStake and RAN Labs have the API services, fully indexed, fully archived nodes, and you can access any of these from your SDK code. And then you got Sandbox, which is basically just install Docker and download Sandbox, and you're good to go. So there it is with the Sandbox. And so to get going with that, you do a Sandbox up testnet if you want to look at testnet. It also supports BetaNet, PrivateNet, and mainnet. So let's take a look at a demo here. I've got a demo for working and creating your first transaction. No, not that one. Yeah, this is the one. So I have a solution here ready to build. I've got the breakpoints already set. This is one's in Java. And what I'm going to do is hit the first breakpoint in my main routine. You see I'm going to call two methods. One is to create an account. And then the second one is to actually do the transaction. So let's go into the first one, creating the account. So there you're just going to do a new account method. This is going to print out down below. You can see the actual address. And then you can also see the passphrase. So this is your secret key. What we're going to do in this example is we're going to restore this account from the secret key in the code. And this is something that you normally would not do in production environment. You're going to use tools like Algo Explorer, Algo Signer, or MyAlgo to do something like that. And then you also need to fund this account. So what we're going to do is we're going to go out to this dispenser. And in the dispenser, we're going to paste in the account, and we're going to dispense funds. Now notice up here, you got zero balance on that account. And the reason we need to dispense funds to this is so you can do transactions. And the transactions have a fee associated with them. And now we're ready to go. Now you can see this dispense 10 algos. Going back out to the code, we'll just go ahead and continue on here. And now, first thing we're going to do in the first transaction is instantiate our client for the SDK. And that is done through the new Algo client SDK call. I'm going to pass in this address, and this is going against my sandbox. So I've got localhost. This is the token, and this is the port. And those are all in the README file in the sandbox when you bring that up. And that is the quickest way to get going is with the sandbox. Now, the next thing, I got a print balance routine. So this is our first client call we're looking at. Now you can see account information. We're going to go ahead and get the address of that particular account. And then you're going to see it display down here in the information down below. So there is the balance that we just printed out over here. And now we're going to go ahead and get the params right over here to do this call. So when I do that, you can see the object. It has things like the fee, the Genesis hash, the ID, the last round. You need to have the last round because many transactions work in like 1,000 round interval. And then we're going to go ahead and construct our transaction object, right? And this is going to have a sender, who it's from, who it's going to go to. We've specified the receiver address up here. We also took that that account, we passed it into this routine here. So we have the account that we have listed on that. The next thing I'm going to do is go ahead and run this transaction. And so when we're going to do that, we're going to run it, we're going to have to sign it first. It gets signed by the sending account. And then we're going to do a raw transaction, which means we're going to broadcast it out to the blockchain. So those three steps are required for all transactions. You want to create the transaction, you want to sign the transaction, and then you want to broadcast it right to the blockchain. So I'm just going to hit run, and then now we're going to wait for confirmation here. Method that we're going to go into that it will look at the transaction pool and see when this thing's actually cleared. And then now it's done clearing, and we've got a bunch of information we're going to print out at the end here with a decoded note that we put in there for hello world. You see the amount, what the fee was, and what the balances out of the 10 that we had there. These are micro algos, by the way, when we looked at that transaction. So you saw a 1 with a bunch of zeros on it, and basically that's what you see down here get displayed. So the amount was for 1 algo, which is, it's got 6 digits of placement on that. All right, next up is going to be Algodia and stateless smart contracts. So let's take a look at that. Algodia is really a great tool. It's an IDE. And this one here, you can see a little bit of a teal, a very simple teal program where you've got a receiver and the address has got to be equal to Bob's address. You're going to see this one here begins with WCM. And the transaction amount's got to be less than or equal to 1 algo. So that's our little bit of logic we're going to do. So in order to do a logic seg or a logic signature, like we had talked about, we're going to go do a stateless contract here, and we're going to generate a logic seg from this. So in order to do this, there's 2 types. You can have a contract account, which just returns true or false and signs it accordingly. But there's also another one here called delegated signature, which in addition to returning true or false, it also has to be signed by an account. We're going to send money from Alice to Bob. The first one we're going to try here is I'm going to hit OK. Now it's going to generate a logic seg that we see right up here. And what I'm going to do is use this to send a transaction. So I'm going to make this fail the first time. I'm going to click Russ Demo to go to rather than Bob. And I'm going to put the 1 algo in, and on the left side of the screen on the bottom, you'll see that this didn't work. This is rejected by the logic. It comes back as false. So anytime you see rejected by logic, that means a teal program did not return true. And let's try this again. So we're going to do a send a transaction, and this time we're going to make the receiver Bob, and that begins with WCM. And we're also going to satisfy the amount requirement with 1 algo, and then go ahead and hit OK. And now it's actually executing this transaction you can see on the left. So this is all done visually, and you can specify where your nodes here are on the right. And really you can do every kind of transaction or every kind of API call visually in this particular tool. This is great for getting set up quickly and getting your test environment going. You can see all the account information. You can list all the accounts like you saw me bring up. You can fetch their balances. You can see if you populated it or not. A lot of great things here with this tool. All right, NFTs. So NFTs can be built using Algorand's ASAs. That's the easiest way to do it, quantity 1. You can also do NFTs in other ways with unique transfer logic built into the stateful smart contracts. You have the ability to build using ASAs manipulated with unique logic signatures, highly configurable between atomic transfers, ASA, and stateful. It's a lot of options there. There's a good article at the bottom that discusses all of those. Let's go ahead and bring up this Minter one. So this is going to create we're going to launch this app to create our own NFT here. Now let's use the algo signer to sign our transactions. Let me get this set up to mainnet. Okay. Oh, there it is. Okay. Now I'm going to mint an NFT. Let's call it Mario. And the URL associated with that image, there it is, comes up, do next. Now it's minting it. Now it goes to Algo Signer, and we're going to say, okay, yeah, let's go ahead and sign that. See, we got 1 asset. There's the fee is going to be 0.001 algos. So this cost me a penny, under a penny every time I do this demo, by the way. And then there you can see now I'm minting my NFT out there, and then you'll see it shortly display on a console with other NFTs that were generated with this. So I'm going to close this up, and then you can see that coming up on this particular page. All right, so those are it's the NFT demo. Then we're going to do atomic transfers, is the ability to wrap multiple items in one transaction. And let's go ahead and show you that in Python. All right, and this code is basically what it's going to do. I got some breakpoints set. We're going to do two things. We're going to send funds from account 1 to account 3. And the amount we're going to send is going to be 1 algo. That's one part of the atomic transfer. The second part is we're going to transfer another set of funds from account 1 to account 2 to account 1. So there you can see the sender and receiver. And this one, we're going to send two algos. Now, both of these must be completed successfully and signed before the transaction is actually broadcast. So here's the process we go through. We do both of these transactions. We get them set up. Then we put a group ID, put them into a group ID for both of those transactions. So now you got a similar group ID for each one. And then you can see the ID number right up there that comes up. And then you also have the signing is next. So we're going to sign each transaction. And then we're going to go ahead and take that signed group. We're going to append them all into the actual send method. So this is the raw broadcast right to the blockchain. And then we're going to wait for that confirmation to appear. And so now we've got both of these transactions going out. We're waiting for the transaction. It's now confirmed. And then you can see the final balances and compare those to the balances that we started with. And you'll see that the funds actually were delivered successfully. Okay. All right, the last piece we're going to get into is dApps, and I want to talk about the architecture here a little bit on a dApp. But basically, you've got a UI or back-end layer with a stateless smart contract, for example, and using Algorand SDKs and REST APIs in the way of doing various transactions. And some types that we have listed here are straight out ordinary payments from one account to another. You have assets. These could be fungible tokens or non-fungible tokens. It could be application transactions for like a stateful smart contract, which is actually stored on the blockchain itself. And there you can see local state might be associated with different accounts and global state available globally. And then one alternative is using PyTeal, and this is pretty straightforward. You create this with Python. You got PyTeal code, and then you have the ability to compile that. And when you compile with PyTeal, you're actually creating teal source, like you saw in that Algo D example. Then with an SDK, you can compile that out to bytecode and then use that. A lot of the calls have a parameter that's associated with that particular bytecode that you've compiled, and then you submit that to the blockchain by creating an app. So now that's the kind of the cycle there with PyTeal development. Reach, I have spent quite a bit of time on in the last few weeks, and very excited to show you the first group to see my new demos on Reach. I know Jason had talked about this at a high level, and I know you got a very deep session coming up on Monday, but I do want to give you a little bit of background here to make your understanding better on Monday when you attend Jay's session as well. So programming language, you have ability to do front ends in the JavaScript, Python, and more. You have a compiler that compiles out to any chain. And then also mathematically guarantee safety, which is very important. And then it outputs an entire application, not just a smart contract. So unlike PyTeal, it's not just a smart contract generator. This is actually generating an entire dApp. And then you deploy it, launches appropriate node and runs test simulations. So with Reach, you basically write once and then deploy to multiple blockchains, Algorand, Ethereum, Complex, more to come. And Reach, in my opinion, is kind of analogous to cross-platform app development. I've done a lot of that in the past. I don't know if any of you have developed apps, but basically, you want to, nowadays, there's a lot of alternatives, right, for creating common code on each platform. You can take one set of code and deploy it and create an iOS app, an Android app, and a Windows app. You can facilitate things like playing a game cross-platform between an Android user and an iOS user. You can have apps go through a certification process as well, right, when they're going to the store. So examples, you know, cross-platform tools, Xamarin, React Native, Unity, Kotlin, Flutter, they all have the same kind of approach. You know, write the code once, deploy it many places. Now, Reach is a cross-blockchain deployment and development tool, right? So you have a front end and back end. And, you know, when you get you know, a great idea in technology, a lot of times it resurfaces with slightly different names. We've had client server, we've had NFT architecture. It's really all about separation of concerns. And so what you do is interact. I got that in quotes because that's actually a verb, a call in Reach between the front end from the back end. And Reach programmers don't need to think about the details, right? You can focus on the business logic, which is beautiful. And you don't have to worry about things like contract storage or protocol diagrams or state validation or network details. It does all of that. And verification and audits is huge. This protects against some of the attacks that we hear about in the blockchain world, like, you know, I've got a contract and it didn't run right, and it automatically creates an account and automatically funds that account. But now the contract is done and I've got no secret key to get at that account that was created because it was created on behalf of this program. And, you know, if it exits and the contract and it's still funds left in that account, that's a problem, right? That you don't want to have as a developer or even worse, as a user, right, of that particular contract. So this guarantees the balance in the contract at the end of the program is zero. Otherwise, tokens can be locked away, inaccessible, and facilitates general blockchain properties like token linearity. So here you have the architecture with JavaScript, Python, and Go, and the Reach front end. And also you have a JavaScript and is like a TypeScript on the back end. The back end will generate and deploy and interact with smart contracts automatically. The Reach front end could be different, right? It could be a JavaScript front end, a Python, or Go, but the back end is always going to stay the same, no matter what front end you got. That's the beauty of this architecture. And then also you have this under the covers uses REST API calls and SDKs and writes out to the Algorand blockchain. Some of you are coming from Solidity development and you have a protocol design, smart contracts, implicit state matches the protocol. You have the middleware, right, that develops a library, uses the SDK or ethers to connect to smart contract. There's a lot of different tools that are used here across this approach to building a dApp, right? Then you have more front-end tools. You have testing, a suite like a developer instance, test consensus network. Verification is provided by a variety of tools and companies. Now that's big. So you know really need to get your dApps audited, right, before you deploy them. And if you just change one thing, then you got to get them re-audited, and that could be a very painful thing to go through. Then you got deployment with deploying to Ethereum. Now I know we got some Ethereum developers here as well. Now what's the difference with Reach? Well, basically with Reach, you do the protocol design through the Reach programming language. Also, you have smart contracts as a Reach compiler. The middleware is a Reach API. You get the idea here. Everything is all included in this development environment. Front end built with JavaScript or remote procedure call language, RPC, support for Python, Go, and more in JavaScript. Then you also have testing. You can do reach run. That's all you got to do, and you're testing away from the command line. Verification. Every Reach compilation includes a thorough, formal verification of the dApp using SMT-based Ethereum provider. So that's beautiful. This is automated, in other words. Deployment, you get a Reach compiler configuration to multiple blockchains. These are very common commands that you run. I actually show you some of the slide. Also, there's some environment variables. This is how you run for ETH or run for Algo or Centrum. There's also the ability to work with accounts if you want to. There's account call methods that you can utilize. Give you some code saving sizes: reach 450 lines, solidity. The equivalent would be 813 and teal over 2000. So results vary. That's just an example. I'm going to show you a Morra game I wrote. Morra is an old Italian game that you have two opponents. They throw fingers out from their hands. So either you can have no fingers or up to 5 each. The opponent throws at the same time and they both yell at the same time what they guess the total will be between the two hands. So let's take a look at this. This will be our final demo today. I like to build things to a crescendo here. Let's go with this one here. So the first thing we're going to take a look at are getting started, right? So what I have here are 2 files. The reach file begins RSH. This is the backend file, and index.mjs is the JavaScript front end module JavaScript. And so when you run from the command line reach init, these 2 files is what it generates that you're looking at. And let's take a look at these. So in the first backend file, it's very, very skeletal. And when you compile, this is what this export constant main will look at. And so this is the main export for the program. And then you want to specify who the participants are to this application right here. So I'm going to have 2 participants, and they'll be called Alice and Bob. Very plain and simple. On the front end side of things, this is where we're going to go ahead and import your backend, which we just looked at. When we run this, it's going to compile it out to this build folder. We'll take a look at the results of that. And then we also have it processes the reach connector mode variable here with that particular line. Then we have a starting balance. So this is on the platform that you're going to be utilizing. So this would be, I'm going to get a unit of 10. So it would be like 10 algos on Algorand and 10 on or 10 on Ethereum. And then you also have this is one of those account methods that you can call, and we're going to take that starting balance of 10 and we're going to populate those into these new accounts. And this only works in the developer testing network. If you deploy to testnet or mainnet, then you'll have to have some additional logic here to maybe transfer funds to new accounts from maybe an escrow you have set up or something like that. So what I'm trying to say is these automatically come from a dispenser that's associated in those networks. Now, Alice deploys the application, and then Bob attaches to it right there. And then finally, we have the initialized backends is done in this section right here. So if I do reach run here, we'll see that this has some messages and it really just doesn't do anything, right? It just comes back, but you do see here what the connector is for. This is going out to ETH. If I want to do an example, for example, for algo, I could do something like this. I can go ahead and take that. Like this. And now you take a look at down below. Now you can see you're on DevNet for Algorand right down below. Also, then what did it actually build? Well, if we look in this build folder, now you can see we got a lot of code in here, and a good part of this is going to be teal that you see right here with algo. And then part of this will be Ethereum because we ran it both ways, right? So you can see that right down over here. So that's all the Ethereum-based code. So that's kind of like the high level there. Now on the game itself, let's go ahead and bring that up. And we're gonna go about 5 minutes over if that's okay with everybody. And we got, okay. So in this code here, let's just run it first. Okay. So now you're going to see some prompts in here. So, and information that comes out. So this is the actual game, right? Alice shoots out 2 fingers and she guesses a total of 4. Bob shoots out 2 fingers and he guesses a value of 2. Well, 2 + 2 = 4. So that's the total actually thrown. And so Bob saw an outcome of Alice that wins and saw the outcome. Now this only does 1 run at a time. There's no while loop in here to keep going until there's a winner. So if this was a draw, maybe they both guessed 4, you'd have to run it again. And we'll take care of that in the next example. But this is where we start seeing on the back end, the interface methods, right, that the front end has, also what the parameters are. And then you also have the parts of the contract that are for Alice only. So she's going to interact and get fingers. So there's a method on the front end called get fingers, and that's what interact means, is go to the front end and execute that. But she's going to get a private variable here called fingers and guess, but then she's going to declassify those and make those available, and then publish it and commit to the blockchain. So both of these values are going to be committed out there. Now Bob, and these are Bob only, Bob is going to do the same thing. He's going to throw 2 fingers out. And by the way, we add in a parameter for the guess because we're going to add on to the fingers that that participant is shooting. So if they shoot 2 fingers, they're not going to guess 1. They're going to guess from 2 on is going to be the value. So that's what we're going to do, is add our random number to the fingers that you are throwing yourself. And we do the same thing down here. So we write that to the blockchain and we commit this space. And then we see what the winning number is. We're going to show that you saw listed in the output. This is the actual logic to the game, not too complex. You know, if both are equal, it's going to be a draw in terms of the guess. If the fingers added together equals what A guessed, then A wins. And if the fingers that added together equals what B guessed, then B wins. Otherwise, it's a draw. So that's it. And then we see the outcome of that match outcome that we run there. Then on the front end here, we actually have the Alice deploys the application to the back end. And then you have the opt-in here to attach to it, like we saw before. We got a few arrays here. I did some testing not to use all 5 fingers. I just did this for, say, 3 fingers each, 0, 1, or 2. And then you have the math compilation for a random number. And then this is the display you see down below for the console log. All right, and that's it. So then if I come up with the next demo here, let's go to or 2. I'm going to have the back end and the front end again. Let's go run this. Oh. All right, there we go. So now we're going to run this, and we're going to have a little bit better of a display on this. And now you can see this is actually looping through a few different rounds, and it's got, you know, on each turn. Oh, and we added wagering into this particular sample. And so we made it a little bit more robust, and we have some security things we'll talk about in a second. But Alice shoots 0 fingers, guesses 1. Bob shoots 3, guesses 8. So this is a full-fledged game, right? We got 0 through 5 each, and it keeps going until there's a guess that's accurate. And you can see this down here where Bob wins, and then there's the wager, right, that he wins in the balances that you have there. And so if we take a look at this one on the back end, we've got a few new things. So these are our arrays that we buffed out. This is the same logic you saw before. Now we have some asserts that we put in here. So this first line is the way the parameters line up in the call to determine the winner is Alice throws a 0, Bob throws a 2. Alice guesses 0, Bob guesses 2. So if that scenario holds, Bob is going to win because that's he got the right one. And these are assets for really for all combinations of fingers and guesses. And then also you have asserts here for a draw, right? So those are all listed there. We've expanded out. We have a timeout factor in here as well. case the user's, timing out. Again, you don't want to lock up funds there. And then you can see here, I'm going to hide my guess because if Bob is a bad player in the original program I showed you, he can interrogate the blockchain and see what Alice's guess was. Here, we're going to make a commitment, right, to keep that a secret. And you do that with the make commitment command. And I do that for both her fingers and her guess. So it has a salt value and you get a commit based on those. So the unknowable tab is used. So with the way this reads is Bob does not know the values of Alice, but Alice does know the values. And then you have your fingers that get interacted on each one there. Alice will declassify the secret information. So now Bob's made his pick already, and now we're going to get her pick back, and then we're going to commit that out and write that out to the blockchain, and then we have the winning number. Now, this last part you can see here is we've got a transfer. This is going to transfer the wages. If I change this to 1, and I rerun this, it's going to bomb, and it's going to say, now, wait a minute. We've got a balance that is not quite right. We've got funds that are basically left over, right? There is no zero balance at the exit of the application. And because we collected 2 five algo bets, and we're only issuing 1 of them. So this is your proof, and it tells you exactly, the line on that's causing that problem. And if I just modify this 1 line, go back to 2, it'll work. If I try to overspend, we're going to get another error, right? That comes back either way. And it's going to say basically you've got balance sufficient for the transfer is not met. All right. So these are the types of things that Breach provides you automatically. And the front end really just created a couple more methods here that are utilized, and then really not too much different there, other than we did put in a little routine to emulate somebody taking their time and to accommodate that for waiting. The last piece of this is the RPC. I'm going to do this one in Python. And so remote procedure call, basically I'm taking that exact same back end that we looked at. I copied it over to this folder, no changes there whatsoever. Now on the Python, what I'm going to do to get this going is I'm going to set up an environment to do this for Python. Okay, and so what I'm going to do here is get 1 line of code here to activate our front end. All right, now you can see the little virtual environment that we have going there. And the next thing we're going to do is, what you would do is install the client that, and these are all written up and really some good documentation available on the Reach site. Now, the last thing we're going to do is we're actually going to run this, and then we'll take a look at the code. So now this is going to run. It's going to actually execute the program. And when it executes, then you'll see the same results. It'll go through the same looping down below, and you'll see the results come out. So on the running of this, then what you'll see here in the front end in particular, let's take a look at that. So the Python front end, what you'll see are a lot of calls like this, RPC and then a finger. So this is really the change. And if you were to do JavaScript the same way, that would happen. And then what you see here, you're going to instantiate the RPC right up front. There are options you can use to pass into that as well, your host, your timeout values, all that kind of stuff. but that's really basically the idea there. Okay, so let's go out then and finish this up. We'll wrap up with some resources and get you on your way today. All right, developer newsletter, it's great. Make sure you sign up for that on the developer site. You get what's new on our developer portal every week. A lot of great programs that the foundation runs. The foundation, for those who aren't familiar, is they're responsible for token economics, different company than Algorand that I work for and Chris works from. And then we also have the 500 ambassadors that are around the world in many, many countries. If you're interested in becoming an Algorand ambassador, drop Stephen at Algorand Foundation. And Chris, can you, if you haven't already done so, paste the link for the deck in the chat. And then we have upcoming developer office hours on Tuesday. We talked about with Yieldy coming up. This is the great slide. You can take a picture of this. Please join our Discord. That's where you're going to get some great support from the community when you're developing your application. This is the link to the PowerPoint you see right here. And then we have some Gitcoin bounties. So do a search on Algorand Foundation. You can see all the different bounties that are up there. And then in summary, we talked about some really cool things here today with blockchain solution ideas to kind of get your head thinking about those. We gave you some really basic getting started, information, as well as a lot of information on layer one. We did spend quite a bit of time on code and tools. Really, the majority of the presentation was on that. In particular, I'm very excited about Reach, as you can tell. Really not much code, and we're creating dApps utilizing that. So hopefully you'll feel the same way we do that, and really hit Jay up for a lot of questions. The rest of the deck are just resources, and we are done. I'm going to go ahead and get out of here, stop sharing my screen, and just see how everybody's doing. Anybody have any comments?
Awesome, and Chris did another great job of answering the questions there in chat. But Chris, were there any that you were not able to answer here in the second half of that?
Let's see. Oh, well, there was one interesting question that I think Russ could definitely pitch into is, what's the difference between Reach and Teal? What's the trade-off?
Yeah, Reach, Teal just is one part of the equation of building a solution. And that's really it. Reach utilizes Teal as part of the solution, but it's more encompassing. You saw a lot of logic, right, that I was putting in on the front end of this application. And also there's verification is automatic with Reach. With if you're just running a Teal program independently, you've got to get an auditor, or you've got to have auditing skills to make sure you've covered every possible scenario. And so that's probably the biggest difference, I think. And really, it's more, Reach is more of a complete development environment for dApps. You can get there, certainly, with PyTeal, utilizing PyTeal to generate the Teal, and then using SDK calls, for example, in the language of your choice, and then tying your application all up with that. And maybe that's more understandable for you, which is fine. But those are the biggest differences. Make sense?
Yes, that's perfect. But I think that's about it. Yeah, everything else is answered.
Awesome, sounds great. Well, thanks again, Russ, for that amazing presentation and demo session there. Those were very informative and very helpful. And just for the audience, we will be including some of the Q&A questions in the post-event summary, as those also were very helpful and useful for kind of understanding everything. But I also did just post the upcoming Reach workshop and the Ideathon workshop coming up next week. So be sure to get tickets for that. And as always, this event was recorded and we'll put onto our YouTube and Medium channel here within the next day. So thanks again for everyone for showing up. And thanks, Chris, for helping out in the chat as well. That was very helpful. But have a great rest of your day, evening, afternoon, wherever you may be located.